This is a motorized rigging session, and today we're going to be dealing primarily with the mechanical aspects of that of that style of rigging. Um, Please note that I keep saying motorized rigging. I have not used the word automation once in my description of this session, um, and I don't think we'll get there because they're different. So we're going to do motorized stuff today. Yeah, if we got time on the back end and we want to talk about some automation stuff, we can, but I have some other things that I want to talk about. However, before we get into the motorized session, I need to talk about what happened last week in New York City. As many of you know, we had a stagehand was killed in a fall at the Winter Garden Theater on Broadway. I do not know any of the details of that accident, and I'm not going to talk about that accident. And that's I'm not going to speculate or anything. All I know is Peter Wright Fallon was killed, and I just want to use that as kind of the impetus to just remind everybody, please keep yourselves out of situations where you have the ability to fall. If there's any situation where that you're in your work situation where you're on in a venue, whatever it is that you're doing, if there is any possibility of your being able to take a fall, take the necessary steps to mitigate that problem, whether it's putting on safety equipment or some other manner. Make sure you protect yourselves 100% of the time. As I said, I don't know what happened. It's a tragedy, and it's making a lot of people very sad, myself included. And I don't want it to happen anymore. And we should be able at this stage of the game to eliminate this. Um, don't do the while I'm standing on this catwalk and I need to reach that instrument, I can't reach it, I'll stand on the railing and just drop the gel frame and it'll be just fine. It's only going to take me 3 seconds. Don't do it. That's when people get killed. Okay, so enough of that, but keep it in mind, please. So rewinding, going back to motorized systems. We're going to be using as our reference, or I have used, I'm not necessarily going to point back to it today, but this is the reference. This is the ANSI standard for power hoist systems, once again available for free from ESTA. If you're involved in designing or building motorized systems, winches, then you need to be aware of this standard. And if you're using winches, this standard is helpful for that also. It'll certainly give you some insight you may not be able to get elsewhere. And just because it's fun to confuse people, this is one of the ways, one of the many ways that the Europeans use, one of the ways that they design their systems, and I'll leave that on the screen for you to read. And while you're reading, and I will tell you that interpreting the SIL standards, if you will, has always been a challenge. And in the time that I've worked in Europe, I can get a different opinion from as many people as I ask. And but it's one of many attempts to identify risk and design a system that avoids risk as much as possible. Canna, do you mind if I put you on the spot? Have you run into this in any of the work that you've been doing over the last couple of years, both in the Middle East and in Europe?
I haven't.
Okay. Well, consider yourself lucky. Right. So now here's a winch, and this is the basis for all motorized systems that we use in the entertainment industry. It's the basis for the lion's share of the automated systems used in the entertainment industry. They may not always look exactly like this, but the basic components are the same. And this type of system has been around, excuse me, has been around for at least 100 years, probably more. We've certainly gotten more sophisticated than what we did 100 years ago, but when we learned about electricity, it wasn't long before we were looking for ways to make our lives easier and move stuff around, make stuff happen, whether it was industrial or commercial or in the entertainment business. And yes, that is a fuzzy photograph. It is not you, but getting good photos of winch systems, at least for me anyway, my experience has always been a challenge. So whether you're flying a piece of scenery up into the fly loft, whether you're dragging, the bedroom scene out of stage right and on stage and then continue off stage left, it's probably going to have a system that will have these components in them. And we'll go through the components first, and then we'll start breaking it down a little bit in terms of how to deal with them, how to use them, and how to maintain them. So let's see, I want to show you I have a couple of other photos. Here's one that's probably a little bit easier to recognize because we added the lift cables on this one. This is a drum winch that has 6 lines on it. And what's the next one here? And there's another one. This one's got the cables. The things sitting on top of the drum are the lift cables coiled up, and like this is apparently getting ready to ship. So let's go back here to Mr. Fuzzy for just a minute or 3 and talk about the components. We're going to work left to right. And the first item we can't see is the brake, the electric brake. There is a brake just inside this cover. When I say there's a brake just inside this cover, and for the rest of the descriptions, you might want to, every once in a while, if I don't do it, throw in the word usually. Some manufacturers, some people will do things a little bit differently because that's what they want to do. I can't predict what everybody's going to do. The functionality of the system will be the same. There's an electric brake here, which sits on a shaft, a metal shaft that runs through the whole system over here. So you have on that shaft, the first item is the brake, then it's the motor, right, which is this guy right here. The smooth cover here is the brake assembly. The motor is right here. And then we have a gearbox. And if you think of a gearbox as like a transmission in your car, hopefully a functioning transmission, that's kind of what it does. And then we have another shaft coming out of that gearbox, runs through the drum and over into this black void that you can't really see what's going on. What is going on over here, and even if the photo was lighter or brighter, you wouldn't be able to see because they got a cover around it. But there is a mounting bracket called a pillow block, which the shaft runs into, and that's where it terminates. So that supports the shaft on this end. In between the pillow block and the drum, there is another brake. And there's also a sprocket in there to help run the limit switch, not to help to run the limit switch, which is that bad boy right here. So power comes in when you turn the machine on by pushing the button, the brake disengages, the motor turns, and the motor doesn't turn, the motor turns the shaft, and that shaft will be spinning on average on a normal everyday winch system. That shaft will be running at about 1750 RPMs. So it'll be spinning like a top as it's coming out of the motor and going into the gearbox. And the gearbox's job, just like on your car, is to take that shaft and control the speed and convert it into power. You know, the motor spinning the shaft at 1750 RPMs, that's really fast, but it doesn't have any power. It's got no torque or very little torque of its own. It needs something else to convert that speed, slow it down, or speed it up, depending on the application. But it needs to, if you're looking for more power, you got to take that shaft, slow it down, and convert it to torque as it comes out on this shaft. And there are 11D7, and you can quote me on that. There are 11D7 gears inside that gearbox that do just that. They take the shaft comes in and starts spinning the gears and running. It runs through the bearings, makes a right-hand turn. This is called a right angle gearbox because it does the shaft. It's a separate shaft. The shaft doesn't actually turn itself, but it's boy, I just got balled up on that one. Shaft in, separate shaft coming out into the drum, but at a right angle, which is why they call that typically a right angle gearbox. All right. So the motor, the brake. Well, let's start with the brake. The brake engages whenever you remove power. So you're holding your finger on the button, on the go button, on the green button, and the winch is running. And then you take your finger off the button. Power is instantly removed from the brake and the motor. The motor stops and the brake engages. Ideally, and it's the way it looks like it's at the same time, like that it's simultaneously, but ideally it's the system is set up that the motor stops and then a nanosecond later the brake engages, right? And it's probably a half a nanosecond. But what so that you have the motor stopping the rotation of the shaft, and then the brake grabs the shaft and hangs on for dear life. And it will not let go until you send power back into the system. Sending power back into the system means pushing that button. And then we do a reverse operation here where the brake will disengage a split in half a nanosecond before the motor starts to rotate the shaft. Clearly, it's important that the brake and the motor operate properly. What you don't want to have happen is the brake engage while the motor is still trying to turn the shaft, or you don't want the brake to disengage. Excuse me. You don't want the brake to disengage and not have the motor turning the shaft at relatively the same time. Otherwise, you burn out the motor, or you have a potential for a runaway. If the brake is disengaged and the motor's not running, the gearbox may not be able to withstand the load, and the winch will turn its operation over to gravity and let gravity do its thing. And so it's important that the brake and the motor have the appropriate relationship, that they engage and disengage at the right time. That's not something that you're going to be able to what's the word? I lost the word. You're not going to be able to identify that as a technician, as the operator of the machine, unless it's so onerous that you can hear it and more than likely smell it. especially if the motor is trying to turn while the brake is engaged. If the motor isn't turning and the brake disengages, it'll tell you pretty quickly that that's going on as the piece starts to descend or move in some way that you had not intended. But assuming that those guys are working properly, they spin that shaft at 1750 RPMs into the gearbox, and the gearbox takes that speed of the shaft, converts it to power, and slows the shaft down. Now, how slow that shaft will rotate as it comes out of the gearbox is dependent upon the design of the gearbox. But typical speeds for drum rotation in a non-critical application where it's the winch is holding is lifting, raising and lowering a lighting batten on stage in the local college, for example, where you're not using it for cues or anything. It's a dedicated electric, and all you have to do is raise and lower it to for maintenance and inspection and to change lights or refocus or whatever. So nobody cares about the speed. You're going to see speeds of usually 16 to 20 feet per minute, which in scientific terms is just crazy slow. But there doesn't need to be a higher speed. If you wanted a higher speed, then you would have to have a different gearbox. The gearbox would have to be spinning the drum faster, which would make the gearbox bigger, probably a little bit more sophisticated, and considerably more expensive. So typical speeds are 16 to 20 feet per minute. And I'm not convinced. And I'm going to I ask one of the old folks here who are up there with me, Michael Powers. Chain hoists have always, a standard chain hoist back in the days when we first started using them up until now, still, they run at 16 feet per minute. A 1 ton or a Lodestar, its normal speed is 16 feet per minute. And I suspect that when people started designing winch systems, they were not for sophisticated or complex scenery moves. They were just to make life easier for technicians, that they copied that speed because that's what they were used to. If somebody has a better theory on why we're moving at those speeds and not say 10 feet a minute or 30 feet a minute, I'm all ears. Okay, then we're off and running. I do not have, well, hang on a second. Let me see if I can get there we are. Okay. Jacob Loretto has asked, well, Michael, I'm sorry. Let me back up and grab some of these because I didn't have my chat. Bear with me while I read here. Michael asked, will the session touch on any one of the manufacturer's products, or is that appropriate for today's session? Paul Taylor put up the link to to answer your question, Michael, we're going to look at package hoist, which is what I think you're referring to, but we're not going to get into product specifications or anything like that. Paul Taylor has put up the link to the standard. Thank you, Paul. And Jack is saying there is a brake slot on the right of the motor. You're right. There is a handle that, is it on the right of this particular motor? Yeah, there it is. I see it. And that is a manual brake release. So when the wheels fall off the bus and everything goes south.
Brake in there, but it looks like it.
Yeah, it's right there. The handle itself is on a couple of little spring clips right there. It sits on the side of the motor, and you need to know what it is. Somebody needs to point it out to you, because there may come a time when you need to lower whatever it is that is hanging out there, but the machine's not working. You could have a power failure, for example, and you want to get, Lady Gaga down from the ceiling. Then you would probably have to take the brake handle off of its little spring clips right here. It's got a threaded end. You thread it right into that slot right there, and then you can move that handle back and forth and slowly release the brake, pull the brake away from the shaft a little bit to hopefully slowly lower a very annoyed Lady Gaga down to the floor. Michael Powers is asking, are the brakes mechanical disc or drum or? The answer is yes. Depends on the style of brake that you are using. Some of them are disc brakes. Some of them are compression brakes where they just squeeze together. And others, they grab the shaft. It's kind of you get to do whatever you want. The only real disc brakes that I have seen, that I have used in the past, are external disc brakes, and they are a secondary or a backup brake typically, and we use them in really heavy situations where we want to have as much safety, much our comfort level requires that we have a backup brake, and it is a disc with calipers on the edge, and depending on how they're programmed, they will engage. They will engage when power is released, but they will engage at a visibly longer time. The system will shut down. For example, I have these on a winch system at Princeton University, very large ceiling reflector, and when the reflector is being repositioned, all the brakes are off. They release the button, the winch will stop running, the winch brake will engage, and then it's like a 3 count, and then the disc brake will engage. It is there to hold the piece in place should everything else go south. And Jack says power is power, no matter what speed. Extremely profound, Jack. Thank you. Yeah, but he's right. The power coming in is going to be whatever it is. It's not what determines the speed. The size of the motor itself and the configuration of the gearbox will determine that combination. Let's see. The power, Michael Powers requires power to release. No power equals full brake action. That's absolutely correct. How can we tell visually if the hoist has a drive-through brake? I can't answer that question. I don't know. Jack?
It's going to be, you're going to have a clutch arrangement with it, so you might be able to tell with a brake like that.
Right. Not terribly common in the systems that we're talking about. Jacob, what's your experience with drive-through brakes? Jacob? Are you muted?
He responded in chat.
Yeah, I don't keep this off mute. Really, for what we're talking about, no experience
Okay.
with them that I know of, and that's why I asked the question.
Right.
How many of these systems maybe were in fact drive-through brakes, and I didn't realize it, like a Vortec, for example. So
So
Clancy
I'm going to
system,
put you on the spot. Well, Michael Powers has put you on the spot. Would you mind defining a drive-through brake?
The brake stays fully engaged while the load is lowered to the ground.
Right.
So I know they exist on large scoreboard systems.
Yes.
And I understand a little bit about it, but it's not something I do. And if there was an opportunity to know more about it, I figured I'd ask.
Yeah, they're not common. I have very little experience other than with scoreboard brakes, scoreboard systems, or a really large acoustical system, like like a really large eyebrow over the front of the apron of the stage.
the original Clancy system had them, but they gave it up because of noise.
Yes. Yep.
And that's part of why I asked, because I'm familiar with some systems that make an incredible amount of noise that are the same era as Powerlift. They're early model Vortex. And
Right.
when there's no load on them and you run the hoist down, it is the most unpleasant noise you've ever heard. And most people who don't know what they're hearing want to run away. And that's part of a brake resurfacing thing. There's more information, blah, blah,
Right.
blah. But I was just wondering if there was like a dead giveaway that, yes, this is a drive-through brake because, that it's a Weston style, or just looking for info.
Right. I think you answered your own question when you said they make a god awful noise.
Only under no load, because
Right.
there's this awful harmonic, but under load, they're quiet.
Yeah.
Sounds fine. Thank you.
Just for everybody else's benefit, we're talking. Jacob mentioned Powerlift and Vortec. They are two brand names of hoists that are sometimes referred to as packaged hoists. Vortec was the first of this particular style of hoist. It came out from the Hoffend and Sons. 25 years ago, maybe more now. I've lost track. Hoffend went out of business and sold the Vortec line to Daktronics, which is the main player in scoreboard hoisting equipment. So a lot of the scoreboard hoists that you see built in the last 15, 20 years are Daktronics Vortec. And it was 3 or 4 years ago, I think now, that Daktronics sold the Vortec line to ETC. Powerlift is the J.R. Clancy line, and it's still with them. They still have that along with a number of other similar products. Clancy is now owned by Wenger, and Wenger is attempting, I don't think they're succeeding, but they're attempting to insert the Wenger name and lose the J.R. Clancy name. But as us old folks, breaking habits is hard. It's very hard.
Too much history there.
Yes. Let's see what I like Canna's comment here. I think speed is originally down to the worm gear in a gearbox left over from manual winches. That makes more sense than just about anything I've ever heard. Thank you. Appreciate it.
Just to say, that wasn't me. That's actually Simon.
I remember it from the early days of manually winching out lighting battens with a driven worm gear. Sorry, a worm gear driving the driven gear on the winch.
Mm-hmm.
And if you let go of the handle, it wouldn't come back in, which also doubled as like a safety, although it had like a ratchet brake clicking over a ratchet wheel on the winch. But
yeah, so
have you got a picture of the inside of the gearboxes? Because I'm interested in the inside of the gearboxes.
I do not have a picture of the inside of a gearbox, but I bet you there's at least 7 people right now, searching for one on the internet.
But God love worm gears. They're great.
Yeah. I would, let's, I'm going to hold the thought on that whole, the comment you made, Simon, about worm gears. And if you let go, it wouldn't reverse. It wouldn't run. I want to talk about that, but well, hell, we could talk about it now. Why not? A gearbox, people will identify a gearbox as a self-locking gearbox if the gear ratio is sufficiently high enough. I've had people tell me that a 50-to-1 ratio, and 50 turns of one equals one rotation, one revolution of the other shaft, right? And they say if you have a 50-to-1 gearbox, that it's self-locking, and if you remove the brake, or if you remove the brake in the motor, it will not backdrive on you. It will not go down of its own accord. And I'm here to tell you from experience that that is not true. A gearbox will hold, but if it's given just enough force to have the piece start to move, when you have a gearbox that has a high ratio, like 50 or 75-to-1, it's what we consider a very efficient gearbox. And that gearbox doesn't give a damn whether it's going up or down. It's still going to be efficient. So I would caution everyone that if you have a gearbox that somebody's saying is a self-locking gearbox, I would err on the side of caution and assume that that is not true, which is why they put those little ratchet devices on the manual winches, because they will back drive. I won't give you the name of the manufacturer, much as I'd like to. It's not somebody that I've already named. It's somebody else. But at the original QVC, if you know the QVC home shopping people, their original TV studios are outside of Philadelphia. And we put in some manual winches that we were told would not backdrive. They never backdrive. They're fine. It's not going to be a problem. We had, and they had a little pin, you matched up the holes, you stuck the pin in as a safety. They had an operator, a young woman, pull the pin, and that handle backdrive so forcefully that it broke her arm.
Yeah, I remember winching them in, and when there was no ratchet on the winching in side of the process, and you could feel once there was a bit of momentum there, you were having to brake with that winch handle.
Yeah.
To prevent it from running.
Exactly.
So yeah.
Yeah, it's and I'll tell you the quick story of how I made the mistake. And this is, I make my mistakes and I try and make them once and then I go on and make a different mistake. But a million years ago, with a brake that had failed, the actual physical brake in the machine, the winch had failed. It had cracked and broken. I was told that this was before my company, but I was working freelance. I was told that the gearbox was a self-locking gearbox. So what I should do to replace the brake was to go and unbolt the motor from the gearbox and pull that out and then disassemble the motor and the brake and put a new brake on. Not being a wise guy, then anyway, I started to unbolt the brake from the gearbox, and as I started to pull the motor away from the brake, the 2,000-pound line array that the winch was holding up started to go down. Fortunately, I had the presence of mind to slam the motor back onto the gearbox, and it held for some reason. But I learned my lesson. And I never allowed anyone to treat a gearbox as a self-locking gearbox, at least not in any of my projects. Going back to the chat, yes, they are AC motors. The other Jack used to say 40-to-1. I think Michael Powers' comment is probably accurate.
Well, it also has to do with how long ago, because gearboxes have become much more efficient. Everybody's worried about efficiency.
Right.
And 40 years ago, nobody gave a you know what. So the 40-to-1 was typically built cheaply enough that it was so inefficient that
Yeah.
but again, that's without a vibrating load or some kind of activity going on. You
Right.
can't count on it. But
Yeah, if you're relying on a self-locking gearbox to hold a piece, and then somebody walks on the unit, takes a step out onto that scoreboard or whatever, that's potentially enough to get that thing to start going south, and it's all over at that point.
the first go around of the standard said that. It said if it was a low efficiency gearbox, that could count as the second brake. But my understanding is that's gone in the latest edition.
Yeah, that is gone, I believe. Okay, so let's move on from the gearbox here. I think for the moment, anyway, we'll circle back to it, but I think we've beat it to death for the moment. We have a shaft coming out, and we got a drum, and the drum is a device that the wire rope or whatever fiber rope, synthetic, whatever it is that we're using as a lifting medium, wraps up on it, and it is going to be a helically grooved drum, which means that when the wire rope starts taking up, like right here, that winch starts to turn and it's lifting the device and the wire rope is wrapping, it is staying in the groove. That groove continues all the way across. Now, let's go to this guy. I think maybe that guy will be, right? So here we are. We have 6 lines on a helically grooved drum. The drum is long enough to allow the cable to wrap around the drum and only have one layer. Right? We don't take and put a second layer on an entertainment winch. I don't know anybody who is doing that, except maybe in some specialty situations. It's a single layer, and the drum is long enough to allow the cable to wrap up next to each other. In this case, the piece has been raised all the way up because all of the cable is on the drum. You can see that there's no grooves left except for what's in between the number 6 line and the number 5 line, and that's that's where the hole is for the cable to go in. So when they want to lower the piece, the cable will start playing off the drum and exposing the drum going from right to left. All right, so hopefully that's clear. And I bring this up because people still tend to, every once in a while, you run into a system where it's a smooth drum. There is no grooving, so there's no control of the lift line. There's no control of keeping it in place, keeping it from wandering around, overwrapping itself, doing all kinds of bad things that could potentially create a problem for you as you're raising and lowering. We don't permit that. The standard doesn't permit it, doesn't permit a smooth drum. The only time you're going to see a smooth drum is, as far as I can tell anyway, is that winch that you mount to the bumper of your Land Rover, or for those of us who aren't in that financial bracket, the 1985 Jeep Cherokee. But yeah, you're going to mount it to your bumper. You're not going to use it in a theatrical application under any circumstances whatsoever. The drum diameter will be determined by a number of things. The first and foremost is the D to D ratio of the wire rope that is being used to pick up the scenery piece or whatever, or even if it is wire rope, because it could be a synthetic line. But if it's wire rope, that D to D ratio is going to determine the diameter of the drum. And the D to D ratio is the diameter of the drum relative to the diameter of the lifting medium, in this case, wire rope. Most manufacturers will use a D to D ratio of between 28 and 32. Clancy's literature right now, I noticed the other day, was showing that they're using a diameter, a D to D of 32 when it comes to 1/4 inch wire rope, you know, for their loft blocks, for example. You multiply 30 times 32 times 0.25, and you get 8.5. Right? Is that the right?
Oh,
one?
you
Yeah.
get 8.
I'm sorry?
You get 8.
Oh, 8. Yeah, excuse me. That's right, because they're loft blocks. The literature that I saw the other day, and I'm on a little bunny trail here, sorry, but the loft blocks have an outside diameter of 8.25. Excuse me, 8.5. But the tread diameter, where the cable actually wraps around the loft block sheave itself, is 8 inches in diameter, which makes that a 32 D to D ratio. My experience in the past, and I'm not sure when they changed, or even if they did, or if they just changed it in their paperwork, is that loft block, the outside diameter has always been 8 inches with a 7.5 inch tread diameter, making the D to D a 28. Exciting stuff. Bear with me for a second. Michael Powers, what about yo-yo drums or the ETC cone-shaped drums, Genie Towers, pitch diameter? All right, slow down, guys. Those are specialty winches, and we're going to get to those, but let's just stay with the generic stuff for just a couple of minutes. All right, and I don't want to talk about Genie Towers at all. I try to never come in contact. I don't want to be in the same time zone as a Genie Tower. We've got a drum. It's a groove drum, and it will take as many cables as you want, as long as the drum is long enough to accept all those lift lines, all those cables, and have enough length to also allow for full travel. So if it wants to travel 50 feet, if the piece wants to travel 50 feet on 6 lines, the drum has to be grooved such that all 6 lines will wrap up full 50 feet of wire rope. I want to go back here for a second. Okay, I think this is probably a little bit easier. So we got a groove drum. I think I've beaten that into submission. Working on the outboard end of the system, there is in here a sprocket. And there is a sprocket mounted onto the shaft. Now the shaft runs out of the gearbox through the drum and into typically a pillow block or some kind of a bearing on the outboard end, so that it's supported. It's just not flapping in the breeze out there, because it wouldn't last more than 3 seconds if it didn't have support. So they put a sprocket on the shaft inside here, and then I'll put another sprocket on this shaft right here, sticking out of this box. This is the limit switch box. And that sprocket to sprocket relationship it handles a roller chain, and it is comparable, and in most cases is no different than the chain on a bicycle. And the size of the sprocket on the shaft relative to the size of the sprocket on the limit switch shaft will provide a one-to-one relationship, so that you can set your limit switches based on the number of rotations of this shaft, so that you can, you can determine, if you want to set the limit switches at 45 feet, you run it up to 45 feet, set the limit switch, then that piece will only run that 45 feet before it hits the limit switch. Okay. We're going to come back to limit switches. I got a better picture of it in just a couple of minutes here. I mentioned that there is a load break down in here too. You can just barely see the tops of them right here, these two plates. And I'm going to do what I hate to do is I'm going to go and find, oh, look, the limit switch. I'm going to go and find, where did it go? See, this is what I hate about this, because I can't see. I can't, like, All right, folks, that's not it. And neither is that. Who wants to, all right. We're back here. I'll find it in a minute. I'm going to have to quit out of the full screen and go back to find that photograph, because it's just not coming up, and I apologize. Michael Borlas has asked, did I pronounce that right, Michael? I think I asked you that last time. I'm not sure.
It's close. I would call it borlace, like shoelace.
Okay, borlace. Okay, great. Thank you. Is there a safety stop function so that if a winch's load gets caught into something, it will stop? And no, there is not. This is a very basic motorized system. We were going to get to the safety aspects of it in a minute, but to address your question now, there is no load sensor, which is usually what is installed on a winch system to catch that sort of thing. If you're raising a pipe and it gets caught on something, you wanted the winch to stop before it damages or breaks something, or causes a problem. Most unsophisticated, but most simple winches like the one you're looking at will not have that kind of a sensor on it. Jack Miller asks about dead wraps. I don't think that's a band, but I could be wrong. But what he's really referring to is the number of wraps left on the machine when you have lowered the piece as far as it will go. You need to have 3 dead wraps on the machine. So, and those the reason you have 3 dead wraps is the friction of the weight pulling on the wire rope wrapped around the drum, trying to compress that drum. 3 dead wraps is the safest, the least number of wraps to have, so that the cable doesn't just come spinning off the pulling out of the winch. So in this particular case, what you were looking for, you run the winch and the unit would go all the way out. So all this cable would play off to the left here, but you would be left with, when you reached the lower limit, you would be left with 3 dead wraps of wire rope in the wrapped around the drum. At the end of those 3 dead wraps, at the very end of the lift line, the cable is tucked back through a hole into the face of the drum. Usually, and not always, you're supposed to have some kind of a stopper mechanism inside to help keep the cable from pulling out of the drum. Not everybody remembers to do that, which is why we want to have those 3 dead wraps, because you want to make sure the cable stays in the hole. Because not everybody will remember to put either a stop sleeve or some kind of a mechanical device in there that will not allow the wire to pull out of the drum. Brian asked, do the 3 dead wraps affect efficiency, capacity of the lifting media? They do not. They do not. What they are there is to prevent the unwinding of the cable off the drum. So they don't have any kind of positive or negative effect on the lifting capacity. So while we're talking about the drum, one more thing, and I was going to mention this later, but now's a good time. On this drum, you will notice there's a big gap here. There's a lot of air underneath the drum, between the drum and the frame. And there's no devices, nothing, there's nothing else there. It's just the drum. Now, if we go to that winch, there's this bar. And what this bar is a device that keeps the wire rope in the groove. And if anybody starts singing and snapping their fingers, leave your mic off. That device, it's a keeper bar, is just there to make sure that should something happen, the cables go slack for some reason, you're lowering the pipe down to the floor, but you forgot that there's a set underneath the pipe, and you land the pipe on top of the scenery. Now all these cables go slack. If they go slack and that bar isn't here, as in that picture, those cables are going to do exactly what they want to do, which is nothing good. They're going to fall off the drum. They're going to wrap themselves around the motor. They're going to, get caught up on the gearbox. And it's kind of a rule. One of them is going to wrap themselves around the sprocket on the limit switch. And if you're not paying attention, and if you don't go and check and see what just happened and make sure that everybody's lined up properly and it's all back in their right grooves and stuff, and you go to run it to take up the slack, because you look at the pipe and the cable's slack on top, and you go, oh geez, and you run it in the other direction, you will snap off that sprocket right there. Right? It's an extremely difficult situation. Winch manufacturers, when they're dealing with these kinds of winches anyway, they don't like to put a keeper bar on there. And the story I get is, well, you don't need a keeper bar because, there's always tension on the drum. There's always some kind of load on the drum. There's a pipe hanging out there, if nothing else. There's always, there's never any release in tension. When is in the theater industry, when has it ever been a never? I mean, we always, something always happens. There's no such thing as never. So you have to combat that. So if you've got a system like this and you don't have a keeper bar that's, keeping your cables on your drum, I would suggest that you put something there. Depending on how big the gap is between the drum and the base here, you could put a 2x4, wood 2x4, 4x4, just bolt it to the base, slam it up against the cables, and then run the winch. The cables will cut a notch, will cut a little groove that is that has, a 32nd of an inch of a gap. And if the cables go slack, they won't come off the drum. If you want to get fancy about it, you slap the 2x4 or the 4x4 down there and then put a piece of UHMW plastic on it as the sacrificial component. Either way, all right. It's just one of those little things you need to look out for. There are many, many, many winches out there that look like this, that don't look like this. All right. So looking at this winch just for the moment, this winch has what appears to be, and this is a photograph, so I can't tell you for sure, but it appears to have either two brakes on the motor end of the shaft, or it's got a brake and some kind of a clutch device. Mr. Powers or Jack or anyone have, if they want to offer a suggestion about what that might be.
No idea.
Yeah.
Looks like there's an encoder.
Say it again?
No clue here either.
Yeah. It looks like a double brake, which now would be a good time to talk about double brakes for just a minute, because this is a conversation that could take 3 weeks. And in some standard circles, it's taken a lot longer than that. double brakes are all the rage these days and have been for the last couple of years because there were certain standards that came out of Europe that required double brakes on lifting media that had were lifting or supporting loads over people's heads. And while I agree, I understand the intent. The implementation has been challenging at best. Putting a brake here on the shaft here, what you are now compensating for is a failure in the other brake, or maybe the motor. But that type of failure, at least in terms of a catastrophic failure where everything is let go and the piece falls to the floor, almost never happens. So a risk analysis looking at that, it's not something that you would look at as a primary issue. In this winch, they've put the brake on the outboard end of the shaft, which is a little bit better because now you're protecting all along this line. I mean, something could potentially break in here and allow the drum to freewheel. The shaft coupling could go, or something on the brake on this side. Who knows? So they put a brake on the outboard, and this is an overspeed brake. So when that drum starts turning too quickly, then that brake will engage. Again, the amount of times that has happened, at least in my experience, not only personally but also in the research that I've done, yeah, you can count it on one hand. Where these systems fail is not in what you're looking at, it's what's connected to the scenery piece or the scenery piece itself. You're not going to get the chances of you getting a failure in a winch system like this, a catastrophic failure anyway, are extremely remote. But the double brake system situation has caught on, and I choose my battles. I certainly am not going to fight that. Okay, so moving on. Look, I just wanted to show you a picture of a helically grooved drum. This is one groove. It starts here and ends over here, and then it does it the same over here, although this one is reversed. So on this particular drum, the cable takes up, when you're lifting the cable, it takes up on this side, and on this side is what it appears to me. Or it might be I know you call them yo-yo drums, but I have a different definition for a yo-yo, where this side is taking up, and this side is letting out at the same time. You would do that on a deck, a piece of scenery on the deck. You want to control it both to pull it on stage and to pull it off stage with one winch. So one line goes to the off stage side, one line goes to the on stage side. And as one side is pulling it on stage, the other side, the other line is coming off the drum, and vice versa. Just wanted you to see that. Line shafts. Boy, I am so oof. Okay, now we're going to go and start it all over again, because I am going to find that photo. Just bear with me here while I open up the program again.
Hey, Bill, if you put it into the mode where you can see all the slides,
Yeah,
you might find it better. It's at the bottom.
yeah. When I do that,
No. Well, yeah, you could do that.
and you guys can see all of that too, right?
Yeah.
That's the one I was looking for. This is the one I was looking for. There's an ugly winch. This is a drive-through brake. It's an overspeed brake on the outboard side of the winch. The motor is on the other end, and I know where this winch. I think it still lives there. And this is a very old photo, so it can't possibly look any better. But that drum is probably about 7 feet long, maybe 7 or 8 feet long. And so we have an overspeed brake here, where when you're lowering the piece empty, you get all of that just awful noise. It's only when you have more tension on the line that you lose that god awful noise. But this gives you another idea. This gives you a good, if not dirty, image of the limit switch and the limit switch chain here. And the other thing I want to point out about a limit switch is its vulnerability. Remember that these systems are not complicated at all. And, the only communication that this winch has for turning off and turning on, other than your finger, is the limit switch inside. And if that chain is not engaged, if that chain is no longer there, for example, and you're running the winch, and that means that the sprocket is not turning, the gears inside the limit switch aren't turning, it's not going to hit anything to tell it to stop until it hits something that you don't want it to hit. There is no safety on this. There is no cover. There is no protection to keep the bicycle chain on that sprocket. And this is extremely common. It is almost the rule, if you will. And these chains, they do fall off. And in this particular case, when that chain falls off, not only does it fall off, but it falls through the grid, and that's 70 feet down to the floor below. And I happen to know in this particular situation that for a fact. So when you're doing inspection and maintenance, the limit switch is an extremely important component of that. Okay, so let's wander back. We're going to look at another style of winch real briefly here. It's a line shaft. The one before this guy, cable drum winch. Now we have a line shaft, and this is just one end of a line shaft. And what it is, you've got a motor, like we had the same motor, same brake and gearbox assembly that we had on the drum winch. But instead of running a shaft directly into a drum, we have a shaft coming off, which is the same style pretty much as a drive shaft in your car. Well, in the cars that I used to drive anyway, long ago and far away. And you can drive as many drums as is appropriate for your application, making sure that you have a gearbox and a motor that are strong enough. They're up to the task of driving, 4, 5, 6, 7, 8 drums. So instead of one drum being driven by a motor, you have multiple drums. There's a fire curtain winch, and this is a line shaft. This is at center stage. This is the whole motor assembly, and we got a dampener here. I'll get into in a minute. But we have shafts coming off both sides, and they are going out to on either side of this winch, there are 2 drums. So you run out about 7 or 8 feet, there's a drum, and then you get another assembly, another shaft attached to the drum out to another drum. So you have 2 on either side of this, and it's used for the fire safety curtain. This bad boy right here, briefly, is a hydraulic dampener, and that acts on the shaft so that when you are lowering the curtain in emergency mode, it will dampen the rotation of the shaft so that the fire curtain comes down in a controlled manner and a slow manner. And it's hydraulic, and you can adjust it. There's somewhere on there, there's a little adjustment valve to adjust the amount of pressure put on by the hydraulic fluid. So it's a way to control the descent of a fire safety curtain in emergency mode. So it's not coming down via electricity or the motor. It is coming down via gravity, and the dampening device is controlling that. Just another photo of a drum with a line shaft coming into it. Let's go back to chat here. There's a couple. Scott Henkels, how much slop is in play in mine shaft systems that have a large quantity of drums with shafts between? Is it ever a concern? Mine shaft. Yeah, I was going to say, I don't know. Yeah, well, that is a concern, and clearly, whoever is designing the system needs to take that into consideration. I have seen line shaft systems that are relatively long, have 6, 7, or 8 drums on them, and instead of having one winch in the center, they will have a winch over on this side and another winch over here on the other side. And so they're shortening the torque, they're reducing the torque they need because they're shortening the shaft. I mean, it would be more challenging for this winch in the picture to turn a shaft that was 40 feet long, for example. You're going to get a lot of torque, a lot of twist in that shaft. So one of the common responses to that is to add more winches, more motor and gearbox assemblies on the line shaft. It creates other problems, but that's another story. Norm to everyone, my fire curtain only had one way to control it, a knife to cut the rope. Did they still have the knife, or did somebody steal it early on? And Camille is correct. The ANSI standard does not permit, E1.22 does not permit, in case of fire, cut this rope. It's not allowed anymore. Yeah, they took the knife off. That's before somebody, took the knife and went and robbed a bank or something, right? Okay, so this just, let's see. Oh, geez, it's really that late already? How did that happen? I'm sorry. Package hoist. We talked about power lifts and Vortec, and there's a Prodigy, and there's another one. They are all variations on a theme. I'm going to use this one as the model because it's got potentially the easiest visual to work with. It's a system for doing multiple lines and in a relatively easy manner. It's called a package hoist because it's kind of like they build them, assembly line, build them, put them in a box, and you can just take them out of the box and plunk them into place, and you don't have to do much of anything else to it. Would that it was ever that simple. What we're looking at here is the whole gearbox and motor assembly over on this end. Here's the drum, and here are the pulleys that are going to divert the lift cables to go out to wherever they need to go. Now, this is a typical orientation for mounting a winch like this, but you could also take it and rotate it and put it up against the wall, so it could be vertical. All right, okay, it doesn't matter. We're looking at it horizontally here. So in the early days, the really big deal about the design of these systems was because they were what we call a zero fleet. This drum, as we talked about earlier, is helically grooved. As the cable comes off the drum, it's going to move in that direction because the groove, it is just one groove and it's just going to track. But as the cable tracks in this direction, the relationship of the cable to the loft blocks is now getting steeper and steeper the further off it goes. And there's a lot of pressure and a lot of force. And well, the best you can hope for is the cable is just going to wear away the groove. And even though you started out with a groove drum, you end up with a smooth drum, which is not something that you want. Right? What you want is this cable coming off the drum, but keeping a vertical 90-degree relationship to this pulley right here. Cable comes up and then it goes out that way somewhere. Right? You want to keep that 90 degrees. The way they do that is that this whole assembly, the whole winch assembly, tracks back and forth. There's a screw jack here, and the other end of the screw jack is over here, which is geared to when you turn the winch on and it starts to rotate the drum, the screw jack pushes the whole assembly so that this line stays vertical. So you keep a 90-degree relationship between the line and the drum. So this drum is going over that way. And that, my friends, is the 30, maybe 45-second description of a packaged hoist. There's another version of it. All the pulleys up in here, drum here. Anybody recognize who this is? I'm not quite sure. I think it's
ETC. I think that's
an ETC,
P75.
right? Say it again.
ETC P75.
P75. Okay. And this is the power lift from Clancy. And I'm not sure whose this is, but again, the drum tracks and keeps the relationship of the cable to this is a single line. It's like a spot line system.
That looks like a one-off kind of thing.
It does, doesn't it? Okay.
Is this so?
Say what?
Is this one maybe a DeSisto? I don't. They still are in business, are they?
I'm not sure. I haven't seen one in a long time, and I'm going to keep my snarky comment to myself. Sorry. I know I'm going to get a call on that one. Actually, it's nah, I don't think so. I don't think so. I don't think it, no, for a host of reasons that I can't go into. Here's a Performer flying winch. You got the same stuff. Motor and a brake and a gearbox and a drum, different looking drum. And the sprocket, limit switch chain, limit switch assembly. What's different for this system from the ones that we just looked at is in the control side, for the most part. You are looking, the control side will have, there will be sensors on here. I can't see them in this photo, but there are slack line detectors. There is overload, as we talked about briefly earlier, an overload protector. When it senses too much force needed, it shuts down. A slack line is usually a trip switch of some sort, where like an eyelash switch, where if the cable hits it, it shuts the system down because the cable shouldn't be there, kind of thing. There will be a potentiometer probably in with the the limit switch housing, which identifies position for the system. But at the end of the day, it starts out with the same basic stuff. You got a shaft running through here and a shaft coming out here. Motor, gearbox, drum. Okay. Limit switch. Now this is a 2-position limit switch. I would have preferred a 4-position, but I couldn't find a good photograph that was legible enough. So we'll go with this. And this is an old, it's an older version, but these styles are still very popular. This one is a GE. The new ones are mostly Italian, but they're the same basic principle. There is a limit switch right here. There's a switch, a magnetics, not a magnetic, a little mechanical switch here and another switch over here. And on these gears, there is a cam, a bump, right? And there it is right here, because that little white stuff signifies where the cam is. It has engaged that limit switch. So what has happened, they've run the unit, this whole assembly, these two sprockets, they go round and round until one of them hits the switch, engages the switch, shuts the system down. Adjustment is done with these two little spring-loaded sprockets here. I'm not going to get into the details of that, primarily because nobody ever taught me how to set a limit switch. And when I first started out, and I spent probably a year cursing everybody I knew trying to figure out how to do it. So, no, I'm kidding. I'm not kidding about that, but I'm kidding. I won't tell you. There are a couple of screws right here. You loosen up the screws, you push down on the appropriate sprocket. This one is for this guy. This one is for this guy over here. It turns the sprocket. So you spin that, it spins this. You put it in the position where you want it, and then you go back and tighten up the screws. Okay. In a 4-pole limit switch, one of these is up, one of these is down, or one of these is in, one of these is out, whatever the action is. Typically these days, there's going to be 4 of these, not just these 2. There's going to be 2 more over on this side. And they're exactly the same. The 4 positions are regular up or in, regular out or down, and then the 2 ultimates, one for up and one for down. If you hit the regular limits, it just stops the unit and you're able to run it in the other direction. If it hits the ultimate, it shuts the system down. It's a safety device. It's there to make you go, what the hell? And go and find out what went wrong. Why did you engage the ultimate? Sort that out before you can reset the limit switch and go about your business. All right. There's a 1-minute version of that. I will also tell you, and this is the one that I did not know, and I didn't find out for probably 2 years. And I think Jack Miller, I think the other Jack had a really good laugh about this one. But this is the cover that goes over this. This device right here that my mouse is sitting on top of is the shaft. And it usually sticks up about a 1/2 inch, 5/8 of an inch higher than the sprocket. Inside this cover is a receiver for that shaft. There's a little cone, if you will, that fits into. When you are testing your limit switches, you must put the cover back on. You don't put the cover back on, and when that cam comes around and hits the limit switch itself, there may be enough force to push the whole sprocket assembly off to the side, and then the cam goes swinging on by and doesn't engage the limit switch itself. It just goes right past it. Right? So if you want to test your stuff and make sure that it's doing what it's supposed to be doing, and you want to make sure that it's in the right location, always put the cover back on top of the assembly before you test it. You don't necessarily have to screw it down, although putting 1 or 2 in sure is easier than going down to the floor 60 feet below to pick it back up again. But that's what you want to make sure that you do that. Right. My advice when you're setting limit switches, or when you're told, when somebody says that you got to go set limit switches, you always just, you run away and you find somebody else to do it, because it's just a royal pain. All right, going back here. That's a Creative Connor. Jack Miller asked, am I sure it's a Performer winch? As far as I know, but that's a Creative Connors system. Is it not a Performer winch, Jack? Jack?
I mean, it could be, but typically they don't do Performer flying.
So Creative Connors?
Yeah. They don't. Gareth doesn't like the liability, which
Yeah,
is understandable.
yeah, but he likes to sell you stuff.
Oh, yeah.
Brian, your slackline sensors are at the head block. So they're not on the winch at all. I'm assuming the head block is a separate element, separate item.
Yeah, this is for I don't want to say too much name wise, but it's a very famous flying effect in Anaheim, California, at a gigantic theme park. And
well, gee, that narrows it down.
Right. The winches are on the 5th floor of the structure. The head block and the diverter block are up about 50 feet above it on the 7th floor of the structure. Right. So the slackline arms are right there where the operator sits with the performer and with the assistant operator. So if something does happen, yeah, that part of it's a design thing that Scott Fisher came up with to put them there. And it's all just that way we don't have to run up and down stairs any more than we already do.
Yeah.
But yeah, it's like you've got that visual thing on all your telemetry on the screen in front of you. The GUI will tell you, hey man, slackline sensor went, but you can also turn to your right and see, oh yeah, I do have a slackline.
Right. All right, great. Yeah, relying on a screen and not having visuals, it's always better when you have both. Always better. And speaking of things going wrong, things to look for, this is, and I believe this is the same winch, that fire curtain winch that I showed you a picture of earlier. When I'm doing an inspection, this is something that tells me, hey, look, we got a problem here, because that means that the shaft or the coupling for the, now you show up when I don't want you. Something has shifted here, because they painted this in a factory and now I got raw material here. It's one of the things that you do not overlook when you're doing an inspection. And I have no idea why I put this picture in here. I looked at this earlier today, so I don't know. I want to go through one. I know we're running late, and those of you who have to go, please do so. But I want to point out a couple of things that I just want to point out this wire rope issue before we get out of here today. With the winches that we've been talking about, with the exception of the performer flying, but the basic winches, they run on an AC current. And when you tell it to run, it wants to run instantly at full speed. And when you tell it to stop, it does instantly. There's no conditioning of the electricity going in. So there's no conditioning of the start or the stop. You get a shock load every time you turn the winch on or turn it off. This can result in significant damage to the wire rope, because that shock load is traveling right through the system. And if you're in if you've got a really, a heavy load and it's on an electric, it's an electric that you use a lot. There's a lot of stopping and starting and stopping and starting. You're going to see shock loads, and they're going to manifest themselves with cable damage that looks like this. What is happening is the wire rope is compressing that, except for this one. This is a kink thing. That's another issue. But this one in particular, and my favorite, we'll go right to this one. What is happening here is the bouncing that you get when you push a button. And the easiest way for most of us to understand this is what happens when you do it with a chain hoist and a truss. You push the button to tell the hoist to take off and take the truss up in the air. It wants to run 16 feet per minute instantly, but it's got 2,000 pounds worth of lighting equipment hanging underneath it, so it can't. So it gets a lurch, and we've all seen that truss bounce, and that bounce transmits back into the system. When it's a drum winch, it's going through, in this case, wire rope, and it creates damage that is, it's aesthetically pleasing, I suspect, to look at, but it's extremely dangerous. Right? What has happened here is this wire rope has been subjected to tension and a release of tension very quickly. It's been bouncing, just like you saw that, just like the truss does. The batten on the electric bounces, or in the case of a number of theaters that I've had to shut down their Eisenhower ceiling systems over the auditorium, the whole ceiling bounces. And, you know, you get these bird cage things, and it's extremely dangerous. And the reason it's dangerous is this bundle right here is the center core. You've been pulling on the wire rope and releasing, pulling on the wire rope, and that center core, because it is the center core and it runs straight through the wire rope assembly, is shorter than the other guys who are wrapped around it. So it takes the load and releases the load a split second before its 6 brothers and sisters. It doesn't like that. And it starts to stretch, and it starts, you know, and it stretches out and forces itself out against the other wire rope. And sometimes you get this, you know, nice looking bird cage thing. Sometimes it's not so pretty at all. And it takes on lots of different manifestations. But that deformation tells me that I have a failure point right in here and right in here, because this hill that's created with the wire rope, that wire rope that had to come from somewhere to allow it to get that high. And it's coming off from right in here and right in here. I got a broken strand right here. I bet you I've got 3 or 4 more on either side. I've lost the center core of that wire rope. And depending on how much weight you've got on that thing, you're about to lose the other 6 too. John Irvin asks, does the shock load situation apply to variable speed motors? It should not, if the variable speed has been programmed properly. There should be an acceleration and deceleration ramp, you know, and it doesn't take much. 1 or 2, maybe 3 seconds of ramping up to full speed and then ramping down to full stop. Scott Parker, good to see you, Scott. Has any manufacturer played with rubber shock mounts? You know, I have seen rubber shock mounts in custom applications maybe a half a dozen times, but they were never there specifically to take out the shock load in the system. They were there as an acoustical treatment. They were trying to reduce the vibration coming from the winch down into the rest of the structure. Yes, and I should have said that. I apologize, Michael. The seizing here, yeah, I'm not quite sure why that it's there. I stole this photograph out of the wire rope user's manual, and that was on it. But the seizing here, or whipping, if you will, means nothing. All right, Billy, take care of yourself. Some Performer flying systems have shock load devices. There's a number of ways of dealing with shock, and you know, we could spend a whole session on that, and maybe we will. But that's not for today, because we're pretty much out of time. What else did I have here? Oh, it's back to that. Yeah, this was the end of it for me. I want to point out that winches require service. The standards state and OSHA state that you gotta do annual service on these things, and that service is, you know, checking all the nuts and bolts and the shaft couplers and all of that, but making sure that if there's, you know, that the brake gaps are appropriate, and the limit switches are doing their thing. You know, it's not just, you know, oh look, it's a winch and it doesn't look broken, you know, looking at it from 5 feet away. You got to do serious inspection and maintenance on them on a regular basis. Annually is usually the appropriate amount of time. The big problem that we have is that when they put these things into a theater, somebody, usually on the sales end, has said, just stick them up in the air. You'll never have to look at them again. You don't need access to them. Just stick them up there and you can forget about them. That's very much not true. And if you're working in a venue now that has that kind of a situation where it's out of sight, out of mind, and you can't get to it, you need to point out to the powers that be that It's the same situation. It's akin to buying a car and then welding the hood shut. You wouldn't do that. You would want to service the motor, or these days have somebody service the engine. And it's the same deal with winch systems. So you need to have that conversation and make sure people either design systems that you can get to, or retroactively you find a way to design a way to get to the system so you can inspect them. They are going to fail without that inspection and maintenance program. They are going to fail. It's not an if, it's just a when. Okay. For those of you who are left, if we're done questions here, I want to remind you that we are doing next week, we are doing part 2 of equity and inclusion. I am going to be announcing some more sessions, hopefully in the next couple of days, which will happen after the holiday, one of which I hope to be a high-end performer flying session. But frankly, I'm not qualified to do that. So I've been speaking with someone who is, and I just got to nail them down and make sure that, he looks me in the eye and says, yes, he will do it. I'm going to do a session on chain hoists because we haven't, and it seems a little odd that we haven't. So, I figure we should do that. And I'm open for suggestions on other topics because, I'd like to keep going with this. Camille asked me why I have such a dislike of Genie towers, other than that they are miserable to use. Well, you started off in the right place. Their use is limited, very limited, and people abuse that all the time. They use them in applications, where they're taking too much weight. They're taking them higher than they should. They're using them outdoors, which is such a bad idea. They really are, a very low end, very small structure kind of lifting device. I would never use them to support. There've been a couple of times when we've used them to raise a rig, and then we, get the towers underneath them and put the towers back, put the roof down onto the towers, and then take the Genies away. We're just using them as a raising and lowering device. They work okay in trade show applications where you don't have, at least not often, you don't have a lot of height or a lot of weight, and you're standing under them when they're going up. Yeah, that's not a nice place to be. My brother convinced me when we were doing those fashion shows in the Celeste Barstow's Forum at the New York Public Library in the early 90s. We were using Genie lifts to raise the rig and hold it. And my brother, who was running that job, didn't like it at all, and he was trying to convince me to go and get a self-climbing, ground support system. And I didn't want to do it because I frankly didn't have the money back in those days. So they raised the roof on these Genies, and he over torqued one of the Genies on purpose. He bent the mast a little bit. And then he called me up and said, "You got to come look at this. Look what happened." He's all upset. And I go in there and I look up and goes, "Oh my God." They brought it down, and I got my checkbook out and I bought my first ground support system. And I found out 10 years later that he had done it on purpose, just so he could get a ground support system. Okay, well, Shannon, thank you. And to everyone, if you've got suggestions, you got some here. Historic rigging such as the late 19th century. Boy, you're really stuck on this, aren't you, Michael? Yeah, we can do that. If you have other suggestions, please send them, let me know, and we'll be happy to entertain them and entertain you with any luck. Thank you all, and have a good night. All right.